Hi everyone, my name is Marius and I quickly want to do a video with you today on the ABCs of ADVPN Phase 1 Configuration Video 2. Wow, what a name. Okay, anyway, so effectively what you want to do, unlike some of my other videos where I do a lot of introduction type videos, today I actually want to dive a little bit deeper into the basic configuration of the ADVPN. So from a configuration point of view, I'll keep it really simple. Alright, however, once we've configured the devices, I want to show you a couple of configuration steps that we've done and what they basically mean. So from that point of view, what we're going to do, it's actually very simple. To keep it really uncomplicated, I've decided not to build all the redundancy and failover and everything else into it, just to keep it to the four main components of this network. The number one thing that you need, of course, is a hub that we know. Okay, so I've created a hub 1 router. Right next to it we have a VAM router, that's VAM 1, alright, that's the second component we'll talk about. And then of course we've got a spoke 1, and so to show you, how this all fits together, I've created a spoke 2 as well. Then we've got an ISP infrastructure that's been set up as well. Alright, in this configuration I'm not going to go through basic setups like IP and so forth. You can see other videos for that. What I want to do though is I want to really focus on the ADVPN side of things. So what's the value of ADVPN and how it's used? Well, you can see the first video that I did on this ADVPN set of videos. There I actually explain what the different components do. What I want to do today is I want to look at the configuration steps of the actual components. Okay, more importantly, so let's just call this guy ISP. The most important thing about ADVPN, what do we know? It builds an overlay network, which means I've got let's say a 192.168.36.0 network here, and this is 192.168.37 network, yeah, and typically I want to push this information across this internet service provider network without him knowing about the 192 networks. So that's important, number one. But more importantly is I want to secure the traffic across this infrastructure. Now in a real scenario we normally would have 2 hubs and 2 VAMs from a redundancy point of view and thousands of spokes, right? And even multiple ISPs. I'm not going to do that today. All I'm going to focus on is 1 hub, 2 spokes and a VAM. I'll also break it down in that specific way, that we'll actually talk about them in that specific way, as how to configure the VAM server, how to configure the spokes, and how to configure the hub. There's slight differences between the hubs and the spokes, and there's quite a big difference from the actual VAM server point of view. I know we can pull this into one router. I'm not doing that today. Alright, I want to make it real, and the reason for that is I want to run debugs on this router, and I'm going to be running a debug on this router, and I'll be running a debug on that router when we're done, and I'm actually going to fire a packet from this spoke 1 to spoke 2 and see what happens. What I'm also doing is, you'll see, I'm going to set up a hub and spoke network. Alright, so what determines a hub and spoke versus a full mesh network? Well, that's all to do with the routing. In my case, I'm going to actually use BGP routing. Okay, so we'll talk about a couple of IP addresses quickly. This is the 202.115.x.y network. Alright, the ISPs themselves. And what I've got is, I've got a 1.1. When I say 1.1, 202.115.1.1 on H1, and I've got a 5.1 on VAM1, and I've got a 10.1 and a 11.1. That's public infrastructure. What I'm doing is, I'm running the 202.115, if I remember correctly, yeah, network. I'm running in OSPF. And this is service provider, ISP network. Yeah, you could run that in anything you want to. I don't really care from that point of view. Whatever type of connectivity. The most important thing is, like we said, if you set up ADVPN, number one, make sure you have WAN connectivity. Okay, activity. That's the first thing you want to do. The second thing we're going to do, once we can actually ping from the VAM server, he's the most important guy for now. Once we can ping all these public IP addresses, and we're sure that that works, right, only then do we move on to the next step. The next thing I'm going to do with the hub and spoke infrastructure is I'm not going to do IPsec for now. Okay, to me that is just an overlay that we configure right afterwards. It's a couple of commands that we can actually add. My most important thing, I want to set up a hub and spoke network over BGP running inside basically my tunnel interfaces, right? And you'll see me doing that. So the WAN connectivity works. The second thing that we want to do is the WAN server. Okay, so let's quickly talk about the WAN server a little bit. So the WAN server works in groups. You'll see when you talk about ADVPN, they talk about a group concept. All right. What they've done is they've pretty much broken, all right, or split the infrastructure into groups. This would pretty much be a group one. Now, I don't want to draw too many lines here, but your hubs will all live in one group. It will be fully meshed with each other. All right. And once you've created one group, what you could do is you could put a bunch of spokes, let's say geographical area, into a group. So a different group. So your hubs would be, let's say, group 1. And let's just do that over here. And this would be group 1. And what you can do at the same time is you can actually create a group 2. A group 2. If you think about this, doesn't it look a lot like an ADR in OSPF? Keep that thought. We'll come back to that point a little bit later. Okay, as we move along in these configuration videos, later on in the videos, I will actually show you how you can use groups to save resources and build out your scalability. All right, on this infrastructure. So for now, let's keep that in mind, all right, that you have the groups. So you'll see me working in a group 2, because at the moment I don't have a second hub here, which means I don't have to set up my group 1. I only have one hub. And I specifically do that so I can really simplify the configuration. You need to see the basic configuration. So when you see me working in group 2 on the WAN server, because I'm going to do that, at some points I will reference the group 2 and I'll set up some stuff in there. Then you understand why we have group 2. Then once we have the WAN server running, the third thing I want to do, this of course is only set up on the WAN server. I'm going to actually set up on, I want to mention here, on the hub and the spokes. Right, I want to set up a WAN client. Okay, that's important. It's not a server, it's a client, which means that they basically utilize the server. Okay, when I set up the WAN client, what you're going to see is quite important, is the way I connect to the WAN client is via IP, and that has got to be the WAN IP. That's why I need to make sure that the WAN connectivity works. That relies on that. If this connectivity doesn't work, this won't set up. Okay, and that's all public IP addressing. Once I've set up the WAN client, and there's a couple of settings in here, like appreciate keys and so forth. Once I've done that, what I'll do is I'll do the ADVPN setup. Now I need you to understand there is no ADVPN on the WAN server. It does not partake in ADVPN. How do we do ADVPN? Well, ADVPN is literally a tunnel interface. So I'm going to create tunnels. Alright, tunnel 0, and inside the tunnel I'm going to associate that with some type of ADVPN domain. Right, and I'm also going to give it an IP address. I'm going to give it a source IP, which basically is the gigabit interface, and you'll see what we're going to do there. Once we've set this up, I'm also going to specify a network that we're going to advertise in here. Once we've set this all up, all right, and this is set up and the WAN client is set up, once we've set all of this up, I'll show you a couple of display commands on the WAN server to make sure that everything is working, and I'll also do it on the hub and of course the spokes. Good. So once you've set up the ADVPN, now we actually have a way of talking to the WAN server. It's going to advertise some routes, you know, public and private IP addresses to the WAN server. And we will have some type of connectivity. But the only thing we have right now is some type of tunneling effect that will come up, a tunnel between the spokes. And more importantly, after that, we're going to basically have to set up a routing protocol. So the fourth thing that we need to set up is something like BGP, so routing. Now this routing, we're going to run BGP. Right, BGP, let's put it that way. Okay, it's quite important. What we're going to do in BGP, and sorry, I'm just going to change colors here quickly. I'm actually going to set up this group here, group 1, for now, as 100. AS100. Let's make it more specific. AS100. Then I'm going to set up these devices over here in AS101. Which means we will have an eBGP connection from the hub to the spoke, and from the hub to the spoke. More importantly, as you'll see, when I set up these spokes, I will only point to the hub tunnel interface as my peer. So I will only peer to him. I will also be running iBGP between these two routers here, but the idea is that it's a hub and spoke environment. Alright, and we don't want to set up a session between these two. That we don't want. We want everything to be hub and spoke. Okay, so if I do a logical representation of that, so the theory behind that, let me just change my colors again, is going to be that I'll actually have a hub router in ADVPN. I'll have a spoke 1 and a spoke 2, and the best way I can think of representing this is a flat network. Okay, and this would be the 10.1.1 network. So let's change color there. This is 10.1.1.0. That's for the tunnel interfaces. So this guy will be tunnel 0, this will be tunnel 0, and this will be tunnel 0. Inside the tunnel 0s, I'll give it an IP address of, let's say, 10.1.1.1 and 10.1.1.3. Why 3? Because later on in the series, I'm actually going to add another hub here, which would be 10.1.1.2. So bear with me for a little bit there. 10.1.1.4. You can see they're all in the same subnet. But what I don't want to do is I don't want this guy to set up a session over there. I want the traffic to flow always through the hub and to the spoke. That's the traffic of direction, traffic flow. So once we get to that point, I'm going to be doing a couple of debugs to show you what you've got to think about to get this working properly. There is some security things we have to talk about, right? Because you'll see that I can actually bypass the system and actually set up a tunnel between the two. Okay, I can also, if I'm not careful, and this is where you automate configuration, but you have to be careful that you really understand the flow of traffic, because I'm going to show you how I send traffic from this point there, it goes down there, and it comes back over this tunnel interface. Okay, asymmetrical routing. Be very careful. There will be two different ways of getting the traffic there. So this is what I want to show you. So once we get there, I'll show you how we fix this problem, all right, and how you need to be wary of that. Okay, so for now, like we said, the 4 steps we're going to have to go through is the WAN connectivity. So let's get there and open some devices. Oh, by the way, I'm running the entire infrastructure on VSRs. Okay, so I've set it up on VSRs, and more importantly, just not on the VSRs, but I'm also running VirtualBox as well, for the people who's interested in that. Okay, so what you'll see here is my VAM server. If I do a display interface brief, you'll see that I've got those IPs that I spoke about. On Gigabit Ethernet 1.0, I've got 202.115.5.1. And effectively it's connected to the 100 network, the 192.168.100. I didn't specify that network, but that network, if I can draw it in here, is going to be over here. That's a 100 network. So this would be a 192.168.100.0 network. Yep, and this guy's got an IP address sitting over here. That's all we're showing you, and that's Gigabit Ethernet 02. Okay, and effectively the Gigabit Ether 1/0 is 202.115.5.1. That's the important IP for now. That's what I want to look at. That's my WAN interface. Okay, so just remember that. Okay, let's just get all our devices up again. Beautiful. So let's go to this guy and we start to ping. And what did we say? Which were some of the IPs? If I remember correctly, ping 202.115. Dot would help a lot. Dot, what do we say? 1.1, that's my hub. Okay, I can ping him, very important. More importantly is, as important, let's put it that way, is my spoke 1 and my spoke 2. In theory, all I have is I've just got connectivity working at the moment. If I do a display OSPF peer, I'm actually peering with the ISP. 202.1.152, right? If you look at the ISP here and you see a display interface brief, you'll see that IP belongs to him, right? 5.2. On his Gigabit Ethernet. So he's basically just connected to all the devices. Okay, and he's only running OSPF if you do a display IP interface brief, right? All he's doing at the moment is basically just those interfaces partaking in the actual process. And if you actually go into a system configuration and display OSPF peer, you'll see he peers up with all the other devices. Okay, so very simple at this point. Maybe what I can also do is OSPF1 and display this. I've actually set it up for the 202 network only, nothing else. And vice versa, and the same is truth over here. All the devices are set up the same way. So if I go and do this, and OSPF1, display this, that's the easiest way to display, is I've only set up for 202. There's no 192 in there. And once we start to ping the 192, what we don't want to see is 192 in these routing tables. And I'll prove it to you when we get there. Okay, and that's of course the easy part done. That's just setting up the basic IP addressing and OSPF. Okay, so one of the things that we have to set up is we have to set up the VAM. Well, this can be VAM client or server. Well, in this case, this guy is really just a VAM server. Okay, he's not going to partake in ADVPN. So I'm just going to set up the VAM server side. So if I say VAM server, and you'll see that it's going to actually ask me for an ADVPN domain. Okay, so that's quite important. When you specify the ADVPN domain, I've discussed in video 1, is a domain normally belongs to a customer. The customer is inside a domain. You could actually split up your customer into multiple domains as well, but we'll talk about that in future videos. For now, we're all sharing the same domain, so let's call it my domain. Okay, so effectively, I first have to pretty much specify an ID for this domain. Okay, so name and an ID. Now I've got the actual domain itself, and what I want to do is I want to enable the server. That's it. Server enable. Right, server is enabled. Brilliant. So at this point, that's the configuration in basic VAM server that's been set up. It knows about no IP addresses because remember, the IP addressing from the hub and spokes can change. So I don't know the IP addressing from the actual spokes and so forth. It's very difficult to predict it right now, so I'm not going to set it up right here. What I want to do is, and I can have multiple interfaces in multiple groups. So that's the important thing. Alright, so basically I've enabled ADVPN. Now I actually have to do the groups. Okay, so what did we say about the groups? Well, okay. Hub group, sorry, I'm confused here. Hub group, and you have to specify the hub group name. Like you can see at the moment, we actually support up to 31 hub groups per ADVPN domain. So if you do run out of hub groups, all right, what you could do is you could have multiple domains connecting to each other. Right, and that's quite important. So a hub group at the moment, and I want to specify the hub group. We said that we're going to use group 2. Inside that, I have to specify my hub IP address. Okay, hub, and basically my, as you will see here, I've got a basic IPv6 or private address. Right, the private address is the tunnel interface that we specified, and we said that the hub's IP address is 10.1.1.1. Okay. And that's basically it. If you do a display this, so in theory, when I get a request from 10.1.1.1, the VAM server, he knows that, oh, by the way, this is a hub, and he will treat it slightly differently to the spoke. Okay, the way they share data and so forth. So it's important for him to know. But if he knows that that's the hub, he also needs to know this spoke addressing. Okay, so once again, I can either do private or IPv6. Okay, in this case, what I'll do is I'll actually do a range. You can do either range or a network, you know, a part of it. So I'm just going to say anything from 10.1.1.3. Remember what we said was 10.1.1.2 is also reserved for hub. To 10.1.1.100 for now. Okay, so it's a whole bunch of them. If I do a display this now, I now have my spokes and I have my private address for my hub. Okay, now this is quite important. If you look at this, if you look at the authentication method, all right. And we do a question mark. There's 3 different ways of doing it. The default is CHAP, there's none, and there's PAP. Okay, so the default is CHAP. So what do we know about CHAP? I need a username and password. Okay, so what we could do is we can actually point to a AAA server right now. I said I'm going to keep it quite simple. So I'm not going to point to a AAA server. I'm going to do the local CHAP, local usernames on the actual router. Okay, and that's the next thing I need to do. Now in real life you don't necessarily want to do this, because if you have 1,500 routers, all with different names and passwords, it's quite a difficult thing to maintain on the VAM server. Okay, especially if one of those routers are compromised, you have to go make a lot of changes. But for now, we're just going to do that. Typically you'd go to a AAA server. Local user, give it a name, let's say hub1. Okay, this is quite important, don't hit enter right now. Right, you have to specify the class as network. So as you say class, and you've got 2 options for that. You've got network or manage, and we're going to say we want to do network. That's important. Okay, so it's now created hub1. What do we need inside hub1? Well, we need a password. Well, we're going to say password, simple, and let's call it hub1. Okay, and then there's got to be part of a service type. Service type, there's lots of service types. It could be, you know, like PPP and so forth, but we're going to use it for ADVPN, this local user. Okay, and if you do a display this, we should have the 3 commands there, which basically says password. Now it's changed to cipher, of course, but it's basically the password, the service type, and the authorization attribute. Alright, so that's all been set up. Now I have to do this multiple times. I have to do this for spoke as well. Okay, Happiness is. So I've got all of that all set up and that's good. Okay, so let's quit out of this one. Happy about that. And we say local user spoke 1 and we said class network. Yeah, still with me on this one. Okay, then we said we got authentication, right? Attribute, oh sorry, first password, and we said simple, and we're going to say spoke 1. We're going to keep them different, and we're going to say service type ADVPN. Okay, 1, 2, 3, and let's make it spoke 2. Sorry guys, I'm just jipping this a little bit, just save some time. And ADVPN, and quit, and display current. I can do a pipe now, but it's so small the configuration at the moment that I can just jump through. So you got a local user called hub1, you got a spoke 1 and a spoke 2. They all have their own IP address, their own passwords, and they're all part of the ADVPN. VAM self, I've got a server enable, right? I've got a hub group 2 and a hub private address and a spoke private address range. That is the configuration for the VAM server. Okay, believe it or not. Okay, right now, let's jump out of this guy, and what I can do is I can display VAM server, but there's not much to see at the moment, alright? One of the interesting things to look at, of course, is the address maps. There's nothing talking to it at the moment. I can talk about private addresses, right? That's been really sent through. Nothing at the moment because there's none of the spokes or hubs connecting to it. Okay, so there's not much to do at the moment. What I can do is term on and term debug, and I can do a debug VAM server, or see if I set up some other stuff, you can see something happening in the background. Okay, so now we've got hub. What do you know about the hub? Well, the hub needs to be a VAM client. Remember, that's what we basically said. So if I set up a VAM client this time, it's not a server, a VAM client, you'll see it's a little bit different. I've got to basically give it a name, and I'm going to call it hub1 for now because it's specific to this one. Okay, hub1, and you'll see there's nothing else I can configure there. Right, then I say basically what it's part of. Now I specify the ADVPN domain, which was my domain. Okay, so if we've done the ADVPN domain, I now have to specify this server primary IP address. Now this address is the VAM server. More importantly about the VAM server, it's the 202 address, the WAN facing 202.115.5.1. Now I've done this a couple of times, so I know the IP address. Okay, and I've got a pre-shared key, right? My key. Thinking about that, I forgot to set up the pre-share key on the VAM server. Okay, that should be simple. My key. Hey, only human, huh? Let's quickly go and set it up. So it was under the VAM server, and we basically said from the VAM server point of view, what we wanted to do was the ADVPN domain was my domain. That's it. Okay, now there, and we have to specify a pre-shared key. That's to get the initial configuration going. Simple my key. This is different from the username. This is just to get the initial configuration going and encryption going. Once we have that, we then start to transfer the CHAP information. Okay. Okay, that's the VAM server, and my hub has now got its pre-shared key. And then I want to specify with what user do I want to go and actually negotiate CHAP. So user we said was going to be hub1. Password is simple and hub1. Okay, if I remember that correctly. And we say client enable. I've now enabled the client. Okay, if you display VAM client FSM, right, you'll see that it's enabled, it's been set up, but at the moment it's pretty quiet on the other side, yeah? Because there's nothing really to share yet. Okay, what I first have to do now is set up the ADVPN. Okay, so let's get into the ADVPN. How do we say we set it up? Well, that's interface, tunnel, 0, mode. What would you say? ADVPN, yeah? And you've got two options, UDP or GRE. For now, there's presentations around why you use one over the other. For now, we're going to use UDP, straightforward, and there's my tunnel. First thing I've got to give myself is a IP address. Once I have an IP address, I need a source interface, and that's going to be gigabit Ethernet 1/0. My source effectively is my WAN interface. Now that I have a way to communicate with the rest of the world, right? I can set up a tunnel. That's important. You see, for the first time now I have an IP address. Up to that point, this guy had no idea, you know, he had no idea to communicate with him. I first have to give this guy an IP address. So that's the 10.1.1.1. So I need to set up the ADVPN before you'll see any action over here. Okay, just don't want it to time out. Okay, so now I've got a source interface, and now I have to client enable this. Right, and so basically what we're going to say there is the VAM client. What do we call our VAM? I remember it was hub 1. Okay, good, and let's say display VAM FSM. Oh, you see a lot of stuff going on next to me, huh? So there's a bit of negotiation going on there. Display VAM client FSM. This time I'm online and active. I'm not going to read all of this back to you, but it's now negotiated with this guy because of the 10.1.1 address. It's negotiated over SHA-1 authentication algorithm, right? And it's used 256-bit encryption. Alright, this is not IPsec. This is just to get the basic tunnel up and running. Okay, we still do IPsec afterwards. The keep alive is 180 seconds, and there's 3 keep alives in between. Yeah, hub number is 1. This guy's hub number 1, and that's pretty much been set up. Okay, I like this. That means that we've got communication. If I do a display VAM server this time, and we do an address map. Alright, this guy is now mapped his 202.115.1.1 address to the 10.1.1.1 address. Okay, we said that's the second thing done that we needed to do. Then we have to set up BGP. I'm doing all of it together so you can get an idea. So my BGP we said was AS100. And I have a peer. What do we say? Well, we can create every single peer, but that's not the idea. I could say 10.1.1.3, but what I want to do is 10.1.1. I want to predict that we're going to come all from the 10.1.1 network. Right, so my tunnel interfaces, I've got control over this. So I can predict this. So we want to say AS number 101. So that's going to be an eBGP peer. Right, so my address family is IPv4. And I say peer 10.1.1.0.24 enable. And once I've enabled the peer, basically what we've done is we've just said, okay, peers don't exist. Oh, 10.1.1.0.24 enable. Okay, let's try that again. 10.1.1.4 AS number. Okay, peer 10.1.1.0.24 AS number 101. Okay, and display this, and we set, yeah, that's why, because I forgot the actual 24. Okay, this time we say, hey, you guys are with me. Love how we make mistakes here. And we say address family IPv4, and we say peer 10.1.1.0.24 enable. This time, let's hope it works. Oh yeah, magic. Okay, amazing what a couple of numbers can do. Okay, what I want to do is I want to advertise my 192 network, 168.100.0, right, inside this network, and that's pretty much done. Okay, you know what, maybe we should just clean this up very quickly and display this. Get rid of this peer, okay, otherwise later on it's going to be confusing. Okay, that's just a keep alive, that's just hello, how are you doing? Okay, so undo peer 10.1.1.0 AS number, I can just do it this way, I think. Display this, okay, peer, there it is. Okay, brilliant, just take a sip of my cold drink. So in theory, looking at this, everything seems to be going pretty well over there, and everything seems to be going quite well over here, so I should be done with that. On the spoke, there's a couple of things that change a little bit. What I'm going to do is I'm going to actually go through the configuration on a notepad with you, because I want to show you the differences between them. Okay, I just tried to show you that at least I know a little bit about how to configure these devices. But there's the VAM server ADVPN domain, right? We spoke about that. We spoke about the hub. Okay, so everything is pretty cool there. So on the spoke side, we've still got a VAM client called spoke 1, ADVPN domain, my domain, right? Server primary IP address is still the 5.1. The pre-shared key is my key. User spoke 1, password spoke 1, client enable, nothing changed here. Yep, are you happy with that? The next thing is the interface 0, mode ADVPN UDP, nothing different. This time it's the IP address is slightly different. of course. The source is still giga10. Why we do that is because if the IP, let's say, is linked to a LTE interface or whatever the case may be, a public interface that could change, alright, you want to basically use the gigabit Ethernet command. ADVPN network 192.168.36. This is slightly different. We didn't see this in the hub. What I am doing is I'm advertising my 192.168.36.0 network, which is my internal network. I'm advertising to the VAM server. Please take note, to the VAM server. This becomes really important, not in this configuration today. In other videos, you'll see how this becomes really important later on. We do intergroup communications. Okay, VAM client spoke 1. Okay, so except for the other configurations, this is different. Keep that in mind. Okay, on BGP, there's also one additional command. Peer 10.1.1, that's fine. You'll see I actually peer directly to the device, to the BGP. I'm not peering to 10.1.1.4. who is going to be set up on spoke 2. I don't want this to happen. If I actually did that, and it's a different way of doing it, but if I created another peer to him, that would become a full mesh. This is how the routing protocol determines whether this is a full mesh or a hub and spoke type topology. Keep that in mind. Your routing protocol determines that. There's no configurations for it. That's how you set up the BGP. Okay, so I'm actually setting up to 10.1.1. That's the only peer, and on spoke 2 I'll set up to 10.1.1. That's the only peer. Okay, in this case, network address family I unicast. That's fine. Network 192.168.36. I'm advertising my network behind the router. The peer 10.1 enable, and then this is important. Peer 10.1.1 allow AS loop 1. What I am doing is allowing that my local AS number is transferred through the hub. Okay, I'll show you when we do basically the BGP. And the reason is because I've got two iBGP devices that wants to talk to each other, right, through an eBGP connection. I need to allow the AS loop 1. It's not a BGP course, but that's very important. If you don't put it in, it won't work. Okay, so it's this line that's different from the hub, and it's effectively this ADVPN command that's different from the hub. Okay, so what I'm going to do is, without further ado, I'm just going to take this and copy and paste it in. Okay, so let's see, that's going to be, I believe, I'm hitting all the wrong devices at the moment. There it is. Okay, sorry about that. Sys, and let's drop this in. Okay. Quit, and we do a display VAM client. FSM. That's negotiating. Let's give it a couple of seconds. Ah, there it is. It's gone. It's done. That's all in buffer. Okay, so that's done. Let's do VAM client 2. Copy and okay, this should be the last time I'm doing all of this, because after this I should have it all done. System, and let's just copy and paste that in there. And we wait for the configuration to happen in the background. That's all of that's just happening at the moment. Okay, great time to take a sip of my cold drink. So, quit out of here. That's all done. Quit out of there. And we display a VAM client FSM. Okay, that looks pretty cool. That's online. Everything is active. And I'll start doing some displays just now. Okay, so that's the configuration done. Basic configuration, everything's easy. Okay, this is where things get interesting, because the majority of people I know stops at this point to go, yeah, it's working, and yeah, it's easy. Okay. And now my question is, how does traffic flow when I ping from spoke 1 to spoke 2? Okay, so if there's CCIEs watching this, or those type of guys, you know, high-end level engineer, master aces and so forth watching this, guys, this is differentiating, I believe, real engineering from, you know, guys who copy and paste, honestly. Okay, so a proper engineer would understand that if this guy's going to ping from this spoke to that spoke, what the traffic flows would look like. He would start anticipating, you know, when would we hit the VAM server, when not. You saw it takes a bit of time to hit the VAM server, so, you know, so how does that affect your VAM server if you actually run a network, right? And what's the reasons for running different types of areas. And I want you to understand that. So in most videos we would stop here and say, well done, job well done, after a bit of a ping. Okay, but what I'm going to do is I'm going to extend this video just a little bit. For everybody that just wants to understand basic configuration, stop watching after I do the ping here, because it'll work and everything will be good. Everybody else that wants to understand what's the flow of data through this network, you can keep on watching. Okay, so if you start to look at this now, think about this. We said that this is basically the 37 network is behind here, and that's a 36. So what I want to do is I want to do a display VAM, sorry, let's do a ADVPN session. Okay, so it's got two sessions set up. That's hub and spoke. These are persistent tunnels. You would have seen that in presentations, yeah? So what happens is there's a persistent tunnel between the hub and the spoke. There's nothing you can do about it. There's a persistent tunnel between hub and spoke. Okay, you can't take it away. It doesn't die. That's the keep alive, so it will keep that tunnel up and running. Alright, as long as there's connectivity, that tunnel will be up. Okay, you'll see that's basically the 10.1.1.3 network and 10.1.1.4 network, and it resolves that to the actual public IP address in ADVPN. Okay, so let's go one step further. If this guy now says, well, display IP routing table to get to the 192.168.36.1 network, that's down to my 10.1.1.3 interface. It's this spoke 1. If I did the same thing for 37, it's down to 4. It's this guy. Okay, so please keep that in mind. So the traffic flow would be from this guy to them. Now, if I did the same thing over here, display BGP, right, routing table, sorry, IPv4. What I'm seeing at the moment from the spoke is that to get to 192.168.36.0, it's connected to me. Next stop is myself, right? So it's right here. 192.168.37, which is this router over here, is 10.1.1.1, which is this router over there. So to get to him, I'm going to have to flow through the hub. You with me? Okay, 192.168.100.0 is what's behind the hub, and that says out of 10.1.1.1. So if I did the same thing over here, display BGP routing table IPv4, to get to the 37 network, we know how to get there, yeah. To get to the 36 network, that's the one that we want to talk about, is a 10.1.1.1. So traffic flow should be up and down and across and back. Everybody with me? Okay, so what I'm going to do, I'm going to say term debugging, alright, and I'm going to debug my ADVPN, and I'm going to say all. Okay, I want to see all ADVPN traffic going across here. I just want to enter this guy so it doesn't error out, so it doesn't time out, sorry, not error out. And I'm going to say thing, what I'm expecting to see is that the traffic should hit the hub and down, yep. And the return traffic should hit the hub and down. So if I do a standard ping with 5 packets, I should see approximately 10 hits on the actual hub. Okay, so that's running the debug there. This guy is, I don't care too much about that. That's just a different protocol coming through. Okay, so let's see if we can find 10 odd pings here. Ping 192.168.37.1. Oh, that would help if I do it the right way. 192.168.37.1. Ooh, I know it's not going to work well. Alright, I tell you why, this actually pinged quite well, but why I'm saying it maybe it didn't work that well is I'm going to show some stuff to you now. Okay, that's quite interesting. What I'm expecting is to just have a hub and spoke session, yeah? So if we do this, display ADVPN session, whoopsie, what's gone on here is that I've got a spoke to spoke session. 19 seconds. Now something's wrong here. Okay, I expected this. I want this to be wrong. Okay, because this is what I said. You know, previous people, if people could ping, they go, yeah, everything is great, it works. What is one of the major advantages? I'm going to explain what just happened here, by the way. Let me get to my whiteboard. There it is. Okay. Oh, lots of drawing. Let's move down. Okay, and let's start drawing now. Okay, so what I said was one of the advantages of a hub and spoke, one of the reasons for hub and spoke would be specifically to set up a security parameter. Okay, so I see a lot of customers saying, no, we do hub and spoke because we want to be secure. So they've got the hub, all right, and they've got the spoke, and they've got the spoke. So effectively what they want to do is, if traffic flows, it's got to flow in this direction, right? And they want it to happen through an infrastructure. The reason is because they can intercept the traffic and they could secure it, whatever the case may be. What they don't want to do is spoke-to-spoke communication. This should not happen. What have we just seen? Well, when we set it up, what we saw is we saw a hub and spoke tunnel being set up. All right, that was there. That's tunnel 1, that's tunnel 2 session. But we also saw a spoke-to-spoke tunnel set up. How did this happen? Okay, so effectively what we are saying is, if you think about this interface there, that guy there, this tunnel interface was 10.1.1.0. Okay, let me draw a little bit differently. Okay, so you understand this concept. So there's the hub, there's the spoke, all right, and I've got a network over there, and a network over there, and connected in this form and fashion. So that's 10.1.1.1, and this is 10.1.1.3 and 10.1.1.4. Okay, and then somewhere along the line there's a VAM server as well. VAM. Okay, that was hit. If you saw the actual debug, it was also hit. So when this guy fired a packet to this network 192.168.37.0, effectively what he did is he created a packet. I'm going to build a packet over here with a source address of 10.1.1.3 and a destination address of 192.168.37.1. Okay, he went into his routing table and said, how do I get to the 192.168.37.1? Oh, that was the 10.1.1.1 tunnel. Alright, so then he knows basically I've got to use this as a source address, you know, the 10.1.1.3. That's the interface. That's how he comes up with the source address. Okay, so the packet fires out, hits the router, this router over here. The router says, well, the destination is 192.168. He doesn't really care about this too much, does he? This got nothing to do with him. Okay, he looks at that and says, well, okay, the destination 192.168.37.1. If you looked at the routing table, it said it was 10.1.1.3. So sorry, 4. Okay, which is this IP address over there. And he fires the packet out, and it hits this router. So what do we see? The initial packet went from there, hub and spoke tunnel. Happiness is. Okay, this guy resolves it because it's that interface, right? And resolves the packet, even if that packet's over there, it doesn't matter. Now the return packet, what would happen, sorry about that, on the return packet what you would see is, and that's what I wanted to do, is this changes. Right, that's the source address at the moment, and that's the destination. So when the return packet comes back, the source would be the 192 source address and a destination address. Okay, so if the source address, remember this changes around, yeah? He's responding to that interface. So as the packet, he looks at his routing table, he goes, wait a moment, in my routing table, how do I get to 10.1.1.3? Remember, it's not source-based routing, this is a router. He looks at 10.1.1.3 and says, how do I get to that? Oh, that's easy. I'm on the same LAN, and fires out of this interface with a destination of 10.1.1.3 and fires it right to this guy. Okay, so you got traffic flowing there, coming down, and coming across. Right. It's got nothing to do with the service provider, because he resolves 10.1.1.3, he resolves to a public address. That's what he does. Okay, it's easy enough for him to pick it up. Okay, so that's one of the challenges that I spoke about. Okay, be very careful there. You don't want to have this communication going. That should not work. Okay, and what you need to do now is, and I would suggest this, is to put a packet folder on the tunnel interfaces and to prohibit the traffic flow from this source address to that source address there, right, going through this interface. So what we're saying is we're permitting only traffic from this source to that destination, and I'll prove it to you. If I ping from this source here of 192.168.36.0, right, it's a different story, because when this guy resolves and the destination is 36, what he'll do is he'll go look at his routing table, and his routing table says it's this interface there, and he fires the packet up back there again, and that's what you want. Okay, this 10.1.1.3, the reason it breaks is because I'm actually using a WAN interface. Now in general life this is not a problem, but from a security point of view, you know, we don't necessarily want to hack you from this interface. What we maybe want to do is create a source of your WAN and actually attack you. I'm just saying, that could be a best practice. Keep that in mind. Okay, so let's see if we can talk about all of this again very quickly and prove what I've just shown you there. So let's just get a couple of these devices back up again. Okay, and get the debugs going again. The debug's still running over here. This guy is still running over there. And what I'm going to do this time, I'm actually going to clear the sessions here. Just display the sessions again. Display. ADVPN sessions. Okay, the session is still there, the spoke-to-spoke session. It's been up for a while, so let's just do a reset. ADVPN session. Okay, this guy is doing a renegotiation of the actual tunnel interface, and if I do a display ADVPN session, now I only have the spoken hub. Now if I do a ping -a, right, coming from 192.168.36.1 going to a destination of 192.168.37.1, right, what basically happens is that's hitting my tunnel interfaces only, and if I do a display ADVPN session, you'll see I only have a spoke to hub, and same thing over here. ADVPN session. Okay, so to prohibit me doing a standard ping like I did before, because look at this guy here, look at him, the debug here. So if you do a normal ping, you see if I do the ping here with my standard configuration, nothing happens to my VM server. I don't have to resolve anything. He's actually there just to build the initial table. Okay, so the session doesn't have to do anything. But if I ping from the 10 network, ping 192.168.37.1, then you can see it hitting the actual device. Right, it actually has to resolve, and basically once it resolves on the right hand side, you can see it basically resolved the 10.113 and basically the networks. Okay, so display ADVPN session, this time it actually built a session. How do we stop this from happening? It's very simple. I go and create an access control list advanced 3000, and I say rule 10 permit IP coming from a source of 192.168.36.0 going to a destination, going to that is there 36.0. You're going to destination, I'm sure. Yeah, wrong parameter here. I thought so. Okay, so rule 10 permit IP coming from a source of 192.168.36.0 going to a destination. Hopefully this time it works, huh? Any, or I can make it 37. Yeah, okay, I permit that traffic and I deny. Maybe I should just do that. Rule 100 deny IP. Okay, then I go to interface a tunnel 0 and packet filter outbound. Okay, I can do it over there as well. For now, I'm not going to set it up right there. That's fine. It's just to do the outbound. If I try and ping it now, ping 192.168.37.1. Alright, won't work because of the access list says there's no ways you can talk to it. Alright, and which means that my sessions will now stay down. Display ADVPN sessions. Let's do that to make sure it resets. Reset. If I leave it long enough, it will basically quit itself, you know. ADVPN session. Good. It's renegotiating session on top. Display ADVPN session, and this time it's there, and I ping 192.168.37.1. Okay, I could also of course do some other stuff as well, funky stuff, but anyway my access list is very basic at the moment. Okay, however, if I ping from a correct source 192.168.36.1 going to 192.168.37.1, this time it works. Right, I hit my hub every single time, and if I display ADVPN session, I only have one session. Okay, I hope this made a bit of sense. At least you've now got a basic understanding of how to configure these basic routers. Right, what we'll do in the next video is we'll enhance that by adding a VAM server. We'll add a hub for now. And once we have that infrastructure running and we understand that concept, right, after that we'll move into multiple groups, and I'll show you the advantages of the multiple groups. Right, what we'll also do, one of the videos ahead, is to actually set up BGP differently. It actually sets up completely differently to be full mesh. Right, and then we can actually create a full mesh environment as well. At this moment it's hub and spoke. We'll show you the full mesh, we will show you the multiple hubs and VAMs and so forth. Right, I hope you guys enjoyed the video, and I hope you guys learned something and you can actually use this. Please come back soon to see some more videos. Thank you very much. Cheerio. Bye bye.